Hello everyone, I am Ms. Megha Karwal, Department of Civil Engineering from Praveen Patil College of Diploma Engineering and Technology, Bangalore. Welcome to all of you in today's lecture. In today's lecture, we are going to start chapter number 3, that is Overview of Bridge Engineering. Bridge Engineering. Bridge Engineering is a branch of civil engineering which deals with the design, construction and maintenance of bridge. Bridge. Bridge is a structure facilitating a communication routes for carrying road traffic or other moving loads over a depression and or obstruction such as a river, streams, channels, roads, or railway. The communication route may be railway track, roadway, footpath, a cycle track, or combination of them. So that's called as a bridge. Okay. So first topic of our chapter is classification of bridge. Bridge may be classified in many ways as a below. First is according to function: aqueduct, viaduct, highway, railway, footbridge. Aqueduct, the drainage structure provided to pass the natural stream without changing its original bed level, are known as a aqueduct. Viaduct, it is a long continuous structure which carries a roadway or railway like a bridge over a dry well is composed of series of spans over the trestle bends instead of solid piers. Footbridge, the bridge excessively used for carrying pedestrians, cycles, and animals across the depression and construction are called as a footbridge. Highway, the bridge used to carry the highway pavements. Railway bridge, the bridge used to carry the railway lines. Next type is according to the construction material. So superstructure as a timber, machinery iron, steel reinforced concrete, pre-stressed concrete, composite aluminum bridge. So timber bridge, the bridge in which the superstructure and substructure is made of the wood or timber bridge. Machinery bridge, the bridge in which the superstructure and substructure is made of the brick, stone or other machinery materials are known as a machinery bridge. Steel bridge, the bridge having their superstructure consisting of iron or steel are known as a steel bridge. RCC and pre-stressed concrete bridge, the bridge having their superstructure consisting of RCC or pre-stressed concrete is known as a RCC bridge or reinforced concrete. Next type is according to the form or type of structure as a slab, beam, truss, arch or suspension bridge. Next type is according to the span length as a culvert. So first is minor bridge, second is major bridge and third is long span bridge. Minor bridge span is less than 30 meter, 8 meter. Major bridge above 30 meter and long span bridge span is more than 120 meter. Next type is according to the level of bridge floor relating to the superstructure as a deck, throw, half throw or suspended bridge. Next type is according to loading. Class AA bridge, Class A bridge, Class B bridge. The bridge designed and constructed for IRC classes like AAA or B loading are known as class bridges or class loading bridges. So next is according to alignment: straight bridge, square bridge. Straight bridge, the bridge having the center line at right angles to the axis of the river is known as a straight or square bridge. Skew bridge, the bridge having their center line not at the right angles to the axis of river is known as a skew bridge. According to the position of high flood level, first is submersible bridge and second is non-submersible bridge. The bridge which allows the high flood water to pass over the superstructure, thereby the submerging the communication routes, is known as a submersible bridge or low level bridge. Non-submersible bridge, the bridge which does not allow the high flood water to pass over its floor carrying the communication route, is known as a non-submersible bridge or high level bridge. Next type is according to life, temporary bridge and permanent bridge. The bridge construction as well as the maintain at low cost and have a short span, a useful life are known as a low cost or temporary bridge. Permanent bridge, the bridge constructed as well as maintained at high cost and have a long span of useful life are known as a high cost or permanent bridge. Component parts of bridge. Any type of bridge divided into the following three types. First is foundation, substructure, and superstructure. Foundation, the lowest artificial built part of abutment, piers, and other similar structure having a direct contact with the subsoil and supporting the bridge superstructure is called as a bridge foundation. Substructure, the lowest part of a bridge consists of the structural system in the form of the abutment, piers, wing walls, etc. along with their foundation which supported superstructure is called as a substructure. Superstructure, the upper part of the bridge consisting of structure system in the form of beam, girder, arches, suspension cables, etc. carrying the communication routes is called as a superstructure. Factors affecting selection of bridge. Subsoil condition. The non-erodible and unyielding soil bed is must for a bridge site. Soil should have high bearing strength. Nature of the river. Width of the river shall be as narrow as possible at side of river, so that the span of bridge is small as possible. Grades and alignments. The stream shall be at right angle to the bridge alignments. Approaches. The bridge side shall have a straight approach. In case of the curve alignment, the bridge should be on the tangent and not on the curve, since it is difficult to construct and maintain a curved bridge. Bank upstream. The stream shall have a permanent, firm, straight, and high banks. Scoring and silting. There should be no scoring and silting of the stream at the bridge site. It should be free from wear and cross current. Next is obstruction and to waterways. There should be a minimum obstruction to natural waterways at the site of bridge. Next is river training work. The stream shall not require costly river training work, construction work inside water. The stream at bridge site should be such that no excessive work is required to be carried inside the water. Availability of free board. The bridge site shall have sufficient free board should be available for ships or boat. Workers and construction material. Locally available materials and labor shall be used to reduce the cost of construction. So these are the factors affecting selection of bridge. Next is collection of design data for a bridge. First is general data. This consists of maps, plans, and topographical feature of the proposal bridge site. It shall contains the following information like name of the approach roads and its classification, name of the stream, location of nearest benchmark and reduced level, changing at center line, maximum recorded intensity, frequency of rainfall, rainfall in centimeter per year, length of catchment, width of catchment, longitudinal slope, etc. Geological data. Nature and properties of existing soil in the bed, banks, and approaches. Safe bearing capacity of foundation soil. Liability of the site to earthquake disturbance and its magnitudes. Third is hydraulic data. This data includes following information like intensity and frequency of rainfall in the catchment area, hydrograph for one or more years, site shape and surface characteristic of catchment area including percolation and interception, observe maximum depth of scour, climate data. This data includes the information regarding annual temperature range, cyclones, wind velocity, rainfall characteristic, and relative humidity. Next is loading and other data. Live load for which the bridge is to be a design as per the IRC code of practice. Type of stream, high water level, low water level, high flood level, ordinary flood level, type and nature of stream, velocity of stream, seismic condition of area. Different technical terms used in a bridge. Effective span. The center to center distance between any two adjacent support of the bridge is called bridge superstructure is called as the effective span. Afflux. It is the rise in a water surface of water course caused due to the obstruction by the breach in the flow of water. The maximum increase in a water level due to the obstruction in the path of flow of water is called as a afflux. Scoring. The process of cutting or depending of the riverbed due to the action of water is called as scoring. When the velocity of stream water exceeds the limit velocity, it causes the vertical cutting of riverbed, which known as a scoring. A difference differs from erosion, which causes horizontal widening of the river. Scour depth, the depth of up to which the flowing stream erodes the soil, is known as a scour depth. Waterway, the section area at the site of bridge through which the water is flow is termed as a waterway. Wing walls, the wall constructed at both the end of the abutment to retain the earth bank of the river or of the bridge approaches are known as the wing walls. Clear span, the clear distance between the two adjacent supports of the bridge superstructure is called as a clear span. Economical span, the span for which the total cost of the bridge will be minimum, is known as the economical span of bridge. Freeboards, it is the difference between the high flood level after allowing the flux, if any, and the lowest point of the point on the underside of the bridge superstructure is called as a freeboard. Low water level, it is a minimum water level in the dry weather. Ordinary flood level, it is a flood level which is normally occurs every year. Curtain walls, the thin wall used as a protection against the scoring action of the river is called as a curtain wall. Thank you.